Good morning, students. Myself, Vijay Shankar from UC Department, Chemical Engineering College. Today, we are going to discuss about the inverse Laplace transform examples. The previous two classes, we completed some examples in the Laplace transform. Now, today also, you can discuss about a few more examples of Laplace transform, and then you go for the inverse Laplace transform. How we can find the inverse Laplace transformation for the given frequency domain function converted to the time domain function. So the wave synthesis using Laplace transform to express the function into singular function and express it in the synthesis. Find the Laplace transformation of the waveform. So there is a slopes given 0 to t. The slope is linearly increases up to the magnitude of a, and t to 3t, and at the 2t it passes to the origin, or the origin it passes at 2t it is a 0, and there is a negative slope is there. Negative slope with minus a is a magnitude, and then from 3t to 4t duration, the positive slope up to the 0 axis at the t. So individually you can find the slopes. Then after you can apply the Laplace transformation to find out the total signal given the x of t. The first of all, if I am taking that as at by t into mu of t is the slope. How? You can take the 0, 0 is the one quadrant. The 0, 0 here, the 0, 0, let us assume 0, 0 is the one quadrant here. And the t comma 0, t comma 0, not the t comma 0, sorry, the magnitude is there. T is the x and a is the y. So the first quadrant you can assume the x1, y1, and second one is the x2, y2. Okay. To find the first slope, the 0 to the up to the t value, this is the first slope. Let us take it is the first one. This is the second slope, and there is a third slope is there. To get it is a fourth also. This is the third one, and the fourth slopes. After combining all the four, you get the x of t, the given signal. The first one, if I am taking the two quadrants here, you know the 5 minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. This is a slight line equation with the slope of m. Y is equal to mx plus c. What is the y here? The x of t. The y-axis x of t minus y1. Y1 is a 0 here. 0. Y2 is a minus y1 is a 0. And x2 is the t minus x1 is a 0. And what is the x-axis having the t variable? So t minus x1 is a 0. So x of t is equal to, we got as a by capital T is a constant and the ramp signal t. We are taking from the 0 to infinite, so it is multiplied with the mu of t. First one, a by capital T into small t is the first slope. X of t we got as a by capital T into small t mu of t. This is the equation. The second one, if I am taking here, with the negative slope is there. It is a negative slope, definitely. Up to the 2t, and from 2t to the 3t, it can take it is another one. And then the 3t to 4t. Following my students. So this slope is extended up to the mark of 2 here, and then you can move this slope towards the negative axis. This is a positive axis is there, towards a positive value, and you go to the minus value. And there is the same signal, but with the shifting of the T samples. The same signal here, that signal is shifted towards the T sample, means now we'll get like this. Add the T. Okay, or it is a small capital T, my dear. Okay. What I am saying that it is a, here the signal is there, x of t, a by t into t, mu of t is shifted towards the T samples. Now what is the value here? Now it gives of x of a by capital T, and this T is now shifted, the T minus T, and it is also the mu of T minus T, mu of T minus T. Got it, my dear students? And why there is a minus 2 is there? It is a negative slope, definitely it is a minus. And whenever there is a positive value here, positive A slope is there, positive A, and this magnitude is a minus A. Here the magnitude is a minus A, my dear students. To get this minus A, definitely that is added with the minus 2A. Plus A minus 2A is nothing but we'll get the minus A. Got it? Is a minus A, negative slope of minus A magnitude. So minus 2A by T, and it is shifted towards the sample of the T. So T minus T, mu of T minus T. Got it, my dear students? So that is the second one. Second slope we got. That second slope is 2 x of t is equal to same signal, but it is a positive A, and this one is a negative A, negative minus A. So to get it is a negative minus A, we can add the minus 2A plus this to the A. So you'll get the minus A by T, and it is shifted towards the T samples. So T minus capital T into mu of T minus capital T. Got it, my dear student? That is the second one. And similarly, the third one you can see, to get it is a third one, add the 3T, at the 3T. I wrote this one is up to the 2T only, T to 2T. And coming to the 3T, and 3T is there, I wrote here the 2A by T and T minus 3T and the mu of T minus 3T, because it is shifted towards the, still it is towards the right side up to the 3T. Okay, but what is the slope here? 2A by T. Why it is a 2A by T? Already we have, it is a minus A is there, minus A. To get it is a positive slope. To get the positive slope here the plus A. To get it is a minus A, we add the A to the minus 2A. It becomes of minus A. Already we have here the minus A. To get it is a positive, you can add the minus A with the plus 2A. Then it becomes of A only. So positive slope. Now the third one again becomes, it is shifted towards up to the 3T, and it is a positive slope coming from the negative values. Got it, my dear students? So third slope we can write it as x of t is equal to, after adding the A with the minus 2A, the slope is minus A. And this minus A slope, to get it is a positive A slope, you can add plus 2A. Got it, my dear students? A, I'm adding the minus 2A, it becomes of minus A. This slope is minus A by T. And this minus A, it becomes of plus A. How? To add the 2A for that one, it becomes A value. Got it? So I'm taking the 2A by T And what is a t? Now the ramp signal is shifted towards a 3t, up to the 3t. So t minus 3t multiplied with mu of t minus 3t. Why I'm adding the multiplying the mu of t minus 3t also? So always it is a shifted towards means up to the infinite. Got it? And at the 4t, there is no any slope. To become it is a 0. Slope is extended like this until. And you have to bring that as a 0 value. 0 value. So already the plus a is there. To get is a 0, you can add minus a. So fourth slope is x of t is equal to a is added with the minus 2a, it becomes of minus a, and minus a is added with the 2a, it becomes of plus a, and plus a is added with the minus a by t, it becomes of the 0 slope, and it shifted towards 4t and mu of t minus 4t. Got it, my students? Okay. So these are the 4 slopes we got from the given signal: positive slope, negative slope, and again positive slope, and it becomes a 0 here. So otherwise, if it is not the 0, it looks like this. Okay, actually it is up to the extended value. Okay, this is a third slope, 2a by t, the t minus 3t and mu of t minus 3t. To become this slope is a 0, then we can take the fourth one is a minus a by t, the t minus 4t and mu of t minus 4t. Got it? The first slope, a by t, the t into mu of t, this is a slope. And second slope up to the 2t, minus 2a by t, the t minus t, mu of t minus t. And the third slope will get at the 3t. So 2a by t, the t minus 3t, mu of t minus 3t. And fourth slope is at 4t. So minus a by t, the t minus 4t, mu of t minus 4t. Okay. The slopes is started at the t. So it is shifted towards t samples. The slope is started at the 3t. So it is shifted towards the 3t samples. The slope is started at the 4t. So it is shifted towards the 4t samples. All the 4 signals you can add. Got it? All the 4 signals you can add: a by t, the t, mu of t, minus 2a by t, the t minus t, mu of t minus t, plus 2a by t, the t minus 3t, mu of t minus 3t, minus a by t, the t minus 4t, mu of t minus 4t. Taking the Laplace transform on both sides, x of t becomes x of x. According to the definition of the Laplace transformation, a by t is a constant. The t into mu of t, the ramp function for Laplace transformation is 1 by s square. Okay, and this is also the Laplace transformation for the ramp only, but shifted with the t samples. So shifted with the t samples means that the t mu of t using the 2 functions, my dear students, here. The Laplace transformation is 1 by s square. And x of t minus t, the Laplace transformation, the shifting second property of the Laplace transformation, time shift property. Okay, but it is e power minus s into whatever the samples is shifted here. Let us take it as the tau into x of s. Got it? What is the x of s here? The t only, because here the t minus t. Shifting is a t minus t, mu of t minus t, so e power minus s, the tau, whatever the value is shifted here, and you can apply the Laplace transformation of x of s, ramp. So see here, minus 2a by t is a constant, and I wrote the 1 by s square because of x of s is there, but it is shifted with the t samples, e power minus s into capital T. And the third term, take the 2a by t, 1 by s square I wrote because it is a x of s ramp function only, but it is shifted with what samples here? 3t samples. So e power minus 3t into s minus a by t into, and again here also the ramp function. First you can apply the Laplace transformation for the ramp is 1 by s square, and that ramp is shifted with 4t samples. So it is multiplied with the exponential, negative exponential, e power minus 4t into s. E power minus 4t into s minus 2. Got it? Now you can take all the terms. There is a common term is a is common term, t is common term, and s square is also common term. So first term it is a 1 minus a by t and s square is gone, 2 into e power minus ts, and a by t s square is gone, the 2 into e power minus 3 ts, and a by t s square is gone, e power minus 4 ts. Got it, my student? This is very, very important. So very, very important example. Remember this one. How we can write these given slopes from 0 to t, t to 3t, and 3t to 4t, and 4t to the remaining functions. There is a 4 slope. Okay, next example, my students. Find the Laplace transformation of the given graphical representation as a square wave. And it is repeated at the interval of 2t, 0 to 2t, and 2t to 4t, and 4t to 6t. Is a periodic signal. Okay, or otherwise we can simply, you see it is shifted with t samples, and again shifted with the 2t samples, and shifted with the 3t samples, 4t samples, and the 5t samples, as usual of the previous example here, as usual of the previous example. But here it is a slope, but slope of with a, and here the magnitude is a 1 only. The magnitude is 1. So no need of it is a mu of t signal only. The mu of t, a simple mu of t signal. And for the second one, mu of t, what is the Fourier Laplace transformation of the mu of t? Laplace transformation of mu of t, 1 by s. See the first one, 1 by s, and it is shifted towards the right side with the t samples. T samples, but it is a minus 2. Why it is a minus 2? Already we have the 1 is there. To get it is a minus 1 negative sample plus 1 minus 2. It becomes of minus 1. Okay. Minus 1 slope, not the slope, minus 1 magnitude. Okay. Minus 2 into 1 by s. Again the mu of t. Because it is shifted with the mu of t minus t. What is the Laplace transformation for this one? E power minus st into 1 by s. Okay. What is the slope here? 1 is the slope, not the slope. Again, I am saying the slope, not the slope, my dear students. It is a magnitude. And here the magnitude is a 1, minus 1. Magnitude is a minus 1. Already we have the 1 is there. So I'm adding minus 2 for the 1 to get it is a minus 1. And at the 2, again it is a 1, positive 1. Because here it is a minus 1 is already there. Mu of t minus t, the Laplace transformation 2t. Now, what is the magnitude at present? Minus 1. To get it is a plus 1, we can multiply minus 2. Not the minus, is a plus 2 to get the plus 1. Plus 2 minus 1 is a 1. What is the Laplace transformation here? Minus st 1 by s, minus 2t. Okay. Now here the 2 is there. To get the minus 1, to get the minus 1. Remember here. For 1, 1 by s, for the first positive cycle here, and t to 2t for the second one, minus 2 into e power minus ts, minus 2 here, minus 2 into e power minus st by s, and then it is a plus 2 into e power minus 2s by s. You got up to the 2t. Now the mu of t minus 3t, mu of t minus 3t, already the 2 is there. To get the minus 1, we can add the minus 3. Okay, to get the minus 1, we can add the minus 2. So plus 2, why it is a plus 2? Plus 2 is a 1, minus 2 is 1 here, minus 2 again. Adding of 2 for the minus 1, we'll get the 1 here. Now 1, to get the minus 1, add the minus 2. So what is the Laplace transformation? Laplace transformation is minus 2 into e power minus s 3t into 1 by s. So after adding the minus 2 for the 1, we are having now it is a minus 1. Again, to get the positive 1, you can add the 2, plus 2. Plus 2 into mu of t minus 4t, plus 2. After adding the plus 2 to the minus 1, we'll get the 1. Again, to get the minus 1, we can add the minus 2. So like that, alternately we'll get the 1 by s minus 2 plus 2, minus 2 plus 2, minus 2, and so on. Got it, my dear students? Understood? So the same way, whatever we are applying here for the Laplace transformation of the waveform for the slopes, here we are finding the slope equation also. But here no need to find the slope equation because it is a ideal characteristics from 0 to 1 is a positive, and t to 2t is a minus 1, and 2t 3t is a 1, and 3t to 4t is a minus 1, and 4t to 5t is a 1, and so on. Got it? The next one, another method is a periodic function. Because it is a periodic function, 0 to t, the value is a 2. Periodicity property can apply. X of s is 1 by 1 minus e power minus 2s into x1 of s. What is the x1 of s? To get this gated function. First of all, you can use the mu of t. What is the mu of t? Is 0 to infinite. The value is 1. And another step function is shifted 3 samples. Now you can subtract these 2 functions. Subtract the 2 functions here, mu of t minus mu of t minus t. So 0 to t, here the 1 and here is a 0. So 1 up to the t. And from t onwards, so here 1 and here 1 minus 1 is a 0. So mu of t minus t is multiplied with, because it is a periodic function, 1 by 1 minus e power minus 2t is, why it is a 2 here? Magnitude is a 2 here. Okay. What is the mu of t Laplace transformation? 1 by s. What is the mu of t minus t Laplace transformation? 1 by s, and it is shifted with t samples, e power minus t into s. Simplify this one, we'll get 2 by s into 1 by 1 plus e power minus s into t. The periodicity property we are applying here. What is the periodicity property? See here, usually in determining the transform of the periodic time functions, x of t is equal to x of t plus n into t, where t is a period. X of s is equal to 0 to infinite x of t e power minus st dt, and 0 to t, t to 2t, 2t to 3t, and so on, nt to n plus 1 into t. Okay. Then x of t is equal to x of t plus t, x of 2 plus t plus 2t, x of t plus 3t, and so on. Follow my dear students. Next step. So x of s is equal to, and so on we are writing. 0 to t, x of t, and 0 to t, and 0 to t, 0 to t. Because it is a periodic function, you can multiply simple 1 by 1 minus e power minus st. Why it is? I already told the sum of n is equal to n1 to n2. A power n is equal to, what is the formula? A power n1 minus a power n2 plus 1 by 1 minus a. This is a formula we have. What is the a here? After expanding this function, e power minus st whole power 0, I'm writing this function, plus e power minus st whole power 1 plus e power minus st whole square, and so on. Okay, means e power minus st whole power n, you can write as 0, 1, 2, 3, and so on, the n, e power minus st whole power capital N, let us see. Now I'm writing the sum of n is equal to, it starts from the 0 and ends at the infinite, that is the infinite. You can take this as infinite up to so on the infinite. Now what is the n1? 0, and n2 is infinite. What is the a here? E power minus st whole power n. So now I'm changing this as sum of n is equal to 0 to infinite e power minus st whole power n. Now instead of a, you can write as e power minus st whole power. What is the n1 here? 0 minus e power minus st whole power. What is the n2 here? Infinite. Infinite plus 1 by 1 minus e power minus st. Because this is a. What is anything power 0? 1. Anything power infinite is 0 by 1 minus e power minus st. Got it, my dear students? So this total equation is equal to 1 by 1 minus e power minus st only. 1 by 1 minus e power minus st. And this function is the definition of the Laplace transformation. 0 to t x of t e power minus st dt. Actually, it is a minus infinite to infinite. It is a finite duration, infinite duration. Now here it is a finite duration is there. So x1 of s only. For a periodic signal, if any periodic signal is repeated for equal interval 0 to t and t 2t to 3t and so on. Got it, my students? That is one of the most important property also. Okay, now you go for the inverse Laplace transformation. I completed the Laplace transformation. Now you go for the inverse Laplace transformation. So inverse Laplace transformation. How you can find inverse Laplace transformation for any given frequency? Now the frequency domain, if it given, convert in the frequency domain to the time domain by using the partial fraction expansion only. By using the partial fraction expansion. Inverse Laplace transformation you can do by using the partial fraction expansion. The inverse Laplace transformation by partial factor method of all the three cases. Case 1, when as domain signal x of s has distinct poles, means the different poles is we have. One is s is equal to 0, another one is s is equal to p1 minus p1, and another one is s is equal to minus p2. Different poles we have. Denominator factors we can call it as a poles. Numerator factors we can call it as a zeros. Remember this one. Okay, typically students they know because they completed the control systems. By using the partial fraction, you can write as A by S and B by S plus P1 and C by S plus P2. Where here I used K1, K2, K3 are the constants instead of A, B, and C. You can use A, B, C also. Where K1 you can find out by substituting S is equal to 0 in these two equations. When S is equal to 0, we'll get K1. When S is equal to minus P1, you get the K2. When S is equal to minus P2 in this equation, you'll get the K3. Then apply the inverse Laplace transformation on both sides. Inverse Laplace transformation of x of s is x of t, and inverse Laplace transformation of 1 by s. 1 by s is mu of t, and 1 by s plus a. S plus a is e power minus at mu of t. And here also 1 by s plus a only. 1 e power minus at mu of t. What is the a here? P2. What is the a here? P1. Okay. This is a case 1. You can find out having the distinct poles and multiple poles we already know the partial fraction, how we can get it is a multiple factors. One pole is s is equal to 0, another pole is s is equal to minus p1, and here there is a two poles are there, s is equal to p2 and s is equal to minus p2, the two poles, because the square is there. You can write as a by s, b by s plus p1, c by s plus p2, and d by s plus p2 whole square. And in this also, you can substitute s is equal to 0 to get k1, s is equal to p1 to get the k2, and s is equal to p square. S is equal to minus p2, you can substitute, you get the k4. So by using the k1, k2 already we get the k4, equate the equations to get the k3 value also. Otherwise you can substitute s is equal to minus, because it is s is equal to something, s is equal to minus p square or something. Or directly you can compare the constant, compare the s coefficients, or compare the s square coefficient, or compare the s cube coefficient, like that. Understood? To find the constants k1, k2, k3, and k4. And then apply the inverse Laplace transformation. 1 by s is mu of t. 1 by s plus a is e power minus at mu of t. 1 by s plus a whole square. 1 by s plus a whole square is t into e power minus at mu of t. When the t is multiplied, the term is get it is a square. In the Fourier transformation also we already discussed that. And here, when the t is multiplied, the Laplace transformation becomes the square of that. Okay, you see here k1 mu of t, k2 e power minus pt into mu of t, and k3 t into e power minus at mu of t, and k4 e power minus at into mu of t. Got it? And the third case we can see here, the third case in general we are saying here, and so on, when it is a square and so on, it is there. You can use it like this. Otherwise, directly can comparing the equations. And third case, complex conjugate poles. Distinct poles, nothing but the different poles. Same poles you can take, the multiple poles we can get, even though you can write it as by substituting the s values as 0 and s is equal to, if any root it is there, substitute and find the constants. And if having the conjugate poles s plus p1 and s square plus bs plus c, the quadratic expression we got. And for that, bx plus c, you see here the a by s plus p1, and here you are using the bs plus c, that b I am taking the k2 plus k3. When there is any quadratic expression is there in the denominator, the partial fractions we can write it as bs, because here the s is the quadratic expression variable. Okay, bs plus c. Here I use that k1 as a and k2 is a b and k3 is a c. Following my students. Now you can write this denominator as a two parts and change the above equation is also according to this equation, because we are applying the inverse Laplace transformation. For inverse Laplace transformation, either it is in the form of 1 by s square, 1 by s plus a, or 1 by s plus a whole square. Otherwise a constant a by s plus a whole square plus a square, like that. For that case, you can get the cos omega naught t mu of t and sin omega naught t mu of t. Cos, you can see the cos always I am said that it is a s is in the denominator, but here the s plus a. When there is s plus a means e power minus at is also multiplied. E power minus at is also multiplied. Remember this one. Again, I am explaining here. E power minus at mu of t. What is the Laplace transformation? 1 by s plus a. And sine omega naught t mu of t. What is the Laplace transformation? Sine is omega naught by s square plus omega naught square. Now these two is multiplied. E power minus at sine omega naught t mu of t. Now what is the Laplace transformation of combining these two? Wherever the s is there, we can replace the s plus a. So omega naught by s plus a whole square plus omega naught square. If suppose it is a cos e power minus at, cos omega naught t mu of t. What is the Laplace transformation? S plus a by s plus a whole square plus omega naught square. Why? When the cos omega naught t mu of t, the Laplace transformation is s by s square plus omega naught square. So wherever the s is there, you can replace the s plus a when it is multiplied e power minus at. So the above equation is also to get in these terms of Laplace transformation, to get the inverse Laplace transformation. S plus a by s plus a whole square omega naught square means e power minus at cos omega naught. And here the s plus a only, e power minus at mu of t. And now you can see here omega naught by s plus a whole square omega naught square. That is equivalent of e power minus at sine omega naught t mu of t. If suppose if I am multiplied for these two functions t into cos omega naught t mu of t, what is the Laplace transformation? When the t is multiplied, it becomes of square s by s square plus omega naught square whole square. The t. I already told the e power minus at mu of t. It becomes of 1 by s plus a whole square. The same thing. The t into e power minus at here, the whole square it becomes. You remember that all the Laplace transformations of the standard signals to find the inverse Laplace transformation. To find the inverse Laplace transformations. Got it, my students? So we completed all the terms, inverse Laplace transformation also. So we'll do some more examples of the inverse Laplace transformation. I'll explain some examples, my dear students, here. The inverse Laplace transformation examples. See, if any time you can be asked the inverse Laplace transformation means definitely it requires ROC also. Not for the standard signals, but if any equation is given, let us x of s is equal to given 3s plus 7 by s square minus 2s minus 3 for ROCs. For the first ROC, they're asking that ROC is greater than the 3. For the second one, for the second ROC, less than minus 1. And third ROC is in between of minus 1 and 3. Okay, minus 1 and 3. So at the different ROCs, it's a different equation we'll get for the inverse Laplace transformation. Okay, my dear students. Now let us see. You can write this as s square minus 2s minus 3 as by using the minus b plus r minus square root of b square minus 4ac, or otherwise you directly can write as x of s is equal to 3s plus 7. Here the minus 2 is there, minus 3. So minus 3 into 1 plus 1. Okay, s square minus 3s plus s minus 3. It becomes of minus 2s only. Take the common here, the 3s plus 7 by, take the first s is a common, s square, not the s square, s minus 3. And for the last two, can take the 1 is a common, s minus 3. So it becomes of 3s plus 7 by s minus 3 into s plus 1. Now you got the factors in the denominator, poles. So x of s is equal to, now I'm writing that is a by s minus 3 plus b by s plus 1. Got it, my dear friends? Now you can equate this function as 3s plus 7 is equal to a into s plus 1 plus b into s minus 3. Got it? Now you can substitute s is equal to 3 in this equation. S is equal to 3 in this equation. S is equal to 3 means b is a 0. B is a 0. 9 plus 7 is equal to a into 3 plus 1 is a 4. 9 plus 7 is a 16. Therefore, a is equal to, what is a is equal to 4? 16 by 4. Now, you can equate the s equations, or you can substitute s is equal to minus 1. Now, I'm equating the s equations, s coefficients 3, a plus b. A is a 4, b is equal to minus 1. B is equal to minus 1. Got it, my dear friends? Now the x of s is equal to a we got the 4 by s minus 3 and plus b is minus 1 by s plus 1. Okay. Now you can write for the first ROC. What they are asking, it is a greater than. Greater than means always is a positive value only. Positive means x of t is equal to, whenever the given it is a one equation, ROC is only the one, either it's a greater than, less than, means you can write positive real axis if it is a greater than. You can write negative real axis when it is a less than. When the combined equations is given, you can see the value here. First of all, I am writing the ROC of ROC greater than the 3, means positive real axis only. 4 into s minus a. S minus a means e power at, 3t into mu of t. I'm writing the mu of t because it is a greater than. Minus 1 is a coefficient. E power minus at mu of t, the Laplace transformation is 1 by s plus a. What is the a here? Minus 3. So minus into minus is a plus, it becomes a 3t. And minus 1 is a coefficient, and e power minus, because it's the plus here, minus t into mu of t. Okay, this is the inverse Laplace transformation for the ROC greater than 3. For the second one you can see it is a less than, they're asking less than the minus 1. Less than the minus 1 means negative relaxes. Negative relaxes. Less than the minus 1. The ROC, you can write here the 3 is there. ROC is above the 3. And the second one, if I am taking the ROC is less than minus 1, the region of convergence is like this. Minus 1, below the minus 1, ROC. Below the minus 1 means mu of minus t. So x of t is equal to 4 and s minus 3 means e power 3t, but it is not the positive mu of minus t. Mu of minus t. And that mu of minus t also, here you can keep the minus also. Minus into e power at. If it is a minus e power minus at mu of minus t, the Laplace transformation is 1 by s plus c. But ROC is different for this one. Okay. And similarly, already we have the minus is there. Now it becomes plus e power minus t is a mu of t. Mu of minus t. So both are minus t's. Okay. Minus e power minus at mu of minus t is a 1 by s plus c for the negative relaxes. It is for the ROC of less than minus 1. But coming to the third one, with the two terms representing in the positive mu of t, and here the two terms representing the negative of mu of minus t. The sign is positive here, the sign is negative. But in this, ROC minus 1 is less than ROC and ROC is less than 3. So observe here, in between of minus 3, minus 1 and the plus 3. So minus 1, ROC minus 1 less than means it is a greater than. ROC is less than the 3 means 3. So in between of the ROC is there. So minus 1 is greater than and 3 is less than. So where the value is, the first value is a 3, because the 3 is less than, you can write here the minus 4 e power 3t mu of minus t. But 1 is greater than, is towards positive relaxes. 3 value is towards a negative relaxes. So the 3 value you can write as a negative relaxes values, and 1 we can write it as a positive relaxes. So e power minus t mu of t I am writing. Here it is a mu of minus t. Remember my students. It is a mu of minus t. Mu of minus t. Got it? This is a third ROC. When it is a greater than means write all the terms is a positive, less than means all the terms is a negative. But whenever it is in the range means ROC, 1 is towards the positive means you can write the mu of t. 3 is towards the negative means write as mu of minus t and keep the sign as negative. Got it, my dear students? It is a very important, ROC is very important to write the inverse Laplace transformation. Definitely we require the ROC only. ROC is a positive or the negative. Okay. Then another example in the inverse Laplace transformation. Using the differential equation. Using the differential equation. What is a differential equation? D square. In the Fourier transformation also we did that some examples. Let us take the one example here. Using the differential equation or by using the partial fraction, not the partial fraction, convolution method. By using the convolution method also, you can find out the inverse Laplace transformation for the given equations. Let us see here. The given it is d square y of t by dt square, the differential equation, plus 4 into dy of t by dt plus 5 into y of t is equal to 5x of t, with initial conditions they are giving y of 0 minus is equal to 1 and dy of t by dt at 0 is equal to 2. 0 minus is equal to 2. And input x of t is equal to mu of t. This is a given example. Now you can find out solve the following differential equation. Solve the differential equation. Apply the Laplace and apply the inverse Laplace transformation also. What is the Laplace transformation of a derivative function? D by dt of x of t. Laplace transformation is s into x of s. Okay, if it is a square, I'm applying the square, is s square into y because it's a y of s plus 4 into dy of t by dt is s into y of s plus 5 into y of s is equal to 5 into x of t. What is the x of t given? Mu of t. Mu of t, the Laplace transformation is 1 by s. Okay, take the term here, the y of s is a common. Y of s square plus 4s plus 5 is equal to 5 by s. Now, write this y of s is equal to 5 by s into s square plus 4s plus 5. What did my dear students? Now, what is the s square plus 4s plus 5? There is no any direct roots we have. Definitely, it is a complex roots only. We'll get the complex roots. If I'm right directly, I'm writing here a by s plus b by, and this function you can write as s plus 2 plus j plus c by s plus 2 minus j. You can multiply these two. S plus 2 plus j, a plus b into a minus b means s plus 2 whole square minus j whole square. Simplify this one, s square plus 4 plus 4s, j square is a minus 1 plus 1 will get s square plus 4s plus 5. Got it, my dear students? These are roots will get a plus b into a minus b. And simplify here to find the a and the b and the c values. What is the a? Substitute any equations. Compare the equations or substitute s is equal to 0. S is equal to 0, you'll get the b and c. S is equal to 2 plus j and s is equal to 2 minus j, can substitute. A is equal to 1 and b is equal to minus j and c is equal to j will get. Okay. So after finding of a and the b, I'm directly writing this equation. Y of s is equal to a is 1 by s, and the b is, what is the denominator here? Plus value. B is minus j by s plus 2 plus j, and c will get plus j by s plus 2 minus j. Got it, my dear students? So y of s is equal to, I'm writing this 1 by s plus, and denominator I'm taking here s plus 2 plus j whole multiply with s plus 2 minus j. What is here? We'll get minus j into s plus 2 minus j plus j into s plus 2 plus j. Now if they simplify here, minus js plus js minus 2j plus 2j, and minus into minus is a plus, j square minus 1, and j into j square minus 1. It becomes of a plus 2 total. If the minus is there, my dear students, so minus j into s plus 2 and plus j into s plus 2. If the minus j into minus j square and j into j plus j square. Okay. J square minus 1. J square is a minus 1, and here the minus 1 is a plus 1 and the minus 1. It is not the same value, my dear students. You're getting the wrong answer. Minus j into s plus 2 minus j, and we'll get the 2 here. S plus 2 plus j and s plus 2 minus j into s plus 2 minus j and s plus 2 minus j, and it becomes a square plus b square, a square minus b square. Okay. So y of s is equal to 1 by s plus, here it becomes of my plus j, my dear students. This is a minus j. Then you can get it is a minus 2. So plus, and here it is a minus plus j into s plus 2 minus j into s plus 2 get cancelled. Plus j into minus j, it becomes of minus j square, and here also the minus j square. Okay, j into j minus j square, and denominator it is s plus 2 whole square minus j square. What is a j square? Minus 1. Minus into minus is a plus. What is a j square? Minus 1. Minus into minus plus. Totally you'll get the 2. So y of s is equal to 1 by s plus 2 by s plus 2 whole square. What is a j square? Minus 1. It becomes of 1 here. What did the students? So now we can apply the inverse Laplace transformation. Apply the inverse Laplace transformation. What is the inverse Laplace transformation here? So for 1 by s, you get the y of t is equal to, what is the 1 by s mu of t? Plus 2 into, 2 is a constant. After getting the 2, you can write as, now I am writing this 1 by s plus 2 into 1 by s plus 2 whole square plus 1 square. You see, it is in the form of sine t mu of t, sine omega naught. What is omega naught here? 1 and s plus 2, because it is s plus 2 is multiplied means e power minus 2t. So 2 into e power minus 2t sine t mu of t is the inverse Laplace transformation. Why I multiply the e power minus 2t? S plus 2 is there. Whenever if it is a s square plus 1 square and 1 is there, that is a sine t omega t only, not the sine t mu of t. What is the sine t mu of t? The Laplace transformation is 1 by s square plus 1 square. When it is multiplied with e power minus 2t mu of t, 2t sine t mu of t, the Laplace transformation is 1 by, wherever the s is there, you can replace the s plus 2 whole square plus 1 square. So mu of t plus 2 into e power minus 2t sine t mu of t. You take the mu of t is a common and right here it is a 1. Got it, my students? If any differential equation is given like this, you can find first of all the Laplace transformation by applying the differentiation property. Then after, you can find inverse Laplace transformation for the y of s value. Got it, my students? And in the given equation, see here, we are not using the y of 0 minus is equal to 1 and the d by dt of 0 is equal to 2. When it is useful, whenever you can apply this as a unilateral. Here I am applying the bilateral. If it is a unilateral means s square y of s minus y of 0 is there. And here also s into y of s minus y of 0 minus. Okay. In that case, it is useful. Otherwise, when directly can apply the bilateral Laplace transformation, no need of using the initial values. No need of the initial values. If it is a unilateral means, definitely can substitute the y of 0 is a 1 and the dy of t by dt is equal to 2. Got it, my students? And in another way, in the Fourier transformation also, we can find the inverse Fourier transformation by using the convolution property. Here also, by using the convolution property, find the inverse Laplace transformation. That is 1 by s square into s plus 2. Find the inverse Laplace transformation by using the convolution property. What is the convolution property? F of s is equal to, it becomes of f1 of s and the f2 of s. Let us, this is a given function is f of s, you can assume 1 by s square into 1 by s plus 2. Okay. F1 of s is equal to, I am assuming 1 by s square, and f2 of s, I am assuming 1 by s plus 2. What is the inverse Laplace transformation for f1 of s? F1 of t is equal to, square means t into mu of t. For mu of t is 1 by s, and it is multiplied the t 1 by s square. And f2 of t, what is a Laplace transformation, inverse Laplace transformation? Because it is s plus a e power minus 2t mu of. Okay, we got in the time domain. What is the convolution? F1 of t with the convolution of f2 of t. The formula is integral minus infinite to infinite. F1 of tau, f2 of t minus tau d tau. Okay. Integral minus infinite to infinite. What is f1 of tau? You can substitute wherever the t is there. That is a tau. Tau into mu of tau. And here the f2, wherever the t is there, t minus tau. E power minus 2 into t minus tau mu of t minus tau d tau. Okay. Mu of tau. What is the mu of tau? Is equal to 1 for tau is greater than or equal to 0. Similarly, mu of t minus tau is equal to 1 when the t minus tau is greater than or equal to 0. And t is greater than or equal to tau, and tau is less than or equal to t. So using these two, tau is greater than or equal to 0 and tau is less than or equal to t, it is in between of a 0 to t on. So I'm changing the limitations now, the 0 to t, tau, and it becomes of 1 and e power minus 2t and e power plus 2 tau beta. Okay, apply the by parts now. That is equal to, this f of t is equal to, as a convolution, e power minus 2t is a constant because it is t value, and tau into e power 2 tau, integral 0 to t, tau into e power 2 tau beta. Integration by parts. So what is the integration by parts here? First of all, if I take the tau and apply the integral here, e power 2 tau by 2 minus, take the integral, apply the derivative here, tau 1, and apply the integral for this one, e power 2 tau by the 2, and with the limitations of 0 to t. Again, inside the e power minus 2t, tau, e power 2 tau by 2 minus, apply the integral here again, e power 2 tau by 4 into t with 0. And these are the values of tau. So e power minus 2t, tau is t, e power 2t by 2, e power 2t by 2 minus e power 2t by 4. Upper limit I am substituting with the two terms. And coming to the lower limit, and the tau is a 0 means third term is a 0, and the fourth term is becomes of e power 0 is a 1 by 4. Okay, now you can multiply this e power minus 2t in the inside, e power minus 2t and e power plus 2t. It becomes of e power 0, 1. So t by 2. And e power minus 2t is multiplied with this one, it is also 1 minus 1 by 4 minus, for this function, e power minus 2t is multiplied, e power minus 2t by 4. So final answer is t by 2 minus 1 by 4 and minus 1 by 4 into e power minus 2t. And here there is a, below I am substituting the lower limit means it is a plus, my dear students, plus it will get, okay, plus value. Upper limit, when I am substituting the upper limit, it becomes of a positive value, and lower limit you can substitute, it is a negative values will get. Got it, my dear students? Now the t by 2, mu of t actually, and 1 by 4 delta of t, and 1 by 4 e power minus 2t into mu of t, all the values. Okay. Inverse Laplace transformation can find out by using either the given distinct poles, multiple poles, or conjugate poles, or otherwise by using the convolution property. Or if any differential equation is given like this, you can find out the inverse Laplace transformation. Okay, you can find out the inverse Laplace transformation. So some more examples you can solve in the lateral, my dear students. What it? So these are the different methods are using to solve the differential equations, or to find out the inverse Laplace transformations. Got it, my dear students? Inverse Laplace transformation. In this also, if I am using this equation is for bilateral Laplace transformation. If it is a unilateral Laplace transformation, see my dear students, if it is a unilateral Laplace transformation, what is a d square y of t by dt square? S square y of s minus s into y of 0 minus minus y dash of 0 minus. So y dash of means nothing but dy by dt plus 4 into, and here 4 into d by dt. What is a d by dt? S into y of s minus y of 0 minus plus 5 into y of s. Okay. Now what is a y of 0 minus is given 1. Okay. And this equation is equal to 5 by s because it is x of s is equal to s square y of s minus s into, what is the y of 0 minus given? 1 minus, and what is the y dy of t by dt y of 0 minus is also equal to the y dash of 0 minus is a 2 plus 4 into sy of s minus 4 y of 0 minus is a 1, so minus 4 plus 5 y of s is equal to 5 by s. Why you have got the y s? mu of t Laplace transformation. Here s square minus s. The constant here we have minus 2 minus 4. Minus 2 minus 4 we got. So that is becomes of the numerator is becomes. I'm writing here, my dear students. Here itself only. I'm removing this one. This is the equation we got the bilateral. Now I'm writing the unilateral equations. Unilateral equation. S square y of s you can take as a common. Here s square and minus 1. Not the minus 1. Y of s is a plus 4. 4s plus 4s. And here plus 5 and other function is there minus s and minus 2 minus 4 minus 6 minus s is there is equal to 5 by s. 5 by s. S square minus s minus 2 plus 4s y of s 4 s into, so y it is a 4 okay 4 s into y of s square plus 4s plus 5 and it becomes of this value. Then what is the y of s here? The y of s is equal to, and take this in the outside, not the outside, of the right side, s square plus 4s plus 5 is equal to, I don't get the minus, and minus 2 minus 6 is a minus 2 minus 4 is a minus 6. The 5 by s minus is plus minus 6 becomes plus 6 here, and minus s is becomes of plus s. Okay, y of s is equal to, take the LCM here, 5 plus 6s plus s square, and denominator we have the s, and this also we can multiply, s square plus 4s plus 5. Now numerator becomes second order and denominator is a third order. Directly you can write as a by s and b by bs plus c into s square plus 4s plus 5. Then you can solve like this by taking off plus j by s plus 2 plus j minus j by s plus 2 minus. So unilateral and bilateral is different. For unilateral, you can use the initial conditions sy of 0 minus y dash of 0 minus and can substitute that values and simplify the equation. Got it, my dear students? Okay. Any doubts is there in the finding of inverse Laplace transformation in the different methods? By giving the ROC greater than, all the terms you can write as positive values. Less than means all the terms you can write as a mu of minus t folded function. If it in the range, in that range you can see which is in the positive direction and which is in the negative direction. Write that values only in the positive and the negative. By using the convolution property also, you can find out the inverse Laplace transformation. And by using the differentiation property also, the given differential equation, you can find out the inverse Laplace transformation. Any doubts, my dear students? Okay. So with this, the Laplace transformation is completed. The 5th unit of triple students is completed, and the 5th unit for the EC students, first part is completed. Okay. Any doubts? Okay. Thank you.